Hello! The double slit interference pattern, first demonstrated by this guy called Thomas Young, was a very important discovery because it provided the first supporting evidence that light is a wave. But have you ever wondered why it took us so long to make this discovery? I mean, it should be very simple, right? Just find two light bulbs, shine them onto the screen, and then see the interference pattern on the screen and then say, wow, light is a wave. Yeah, unfortunately, it's not so simple, yeah? For two reasons. First reason, the light emitted by two light bulbs are not coherent. The two light bulbs actually do not emit light waves that's a continuous sinusoidal function. Instead, they produce light waves that look more like this. The light emitted is emitted in bursts, short bursts of just a few nanoseconds. So this is what I call an artist's impression, yeah? Because in just a few milliseconds, if you're talking about light waves, there are already millions, if not billions of cycles, not just two cycles. That's why I say this is an artist's impression. Also, the bursts are not always equally long, yeah? Sometimes a burst lasts longer, sometimes a burst lasts shorter. But the key thing is this, the two light bulbs are not going to coordinate with each other when they are going to switch and what they are going to switch into. So the light that's leaving the two light bulbs could be in phase during one burst, but become completely out of phase in the next burst. What that means is that a spot on the screen here could be a bright fringe for a few nanoseconds, but become a dark fringe in the next few nanoseconds. And this happens at every positions along the screen. So instead of bright and dark fringes, you're going to get an averaged brightness everywhere on the screen. That's why if you use two light bulbs as your two light sources, you're not going to see an interference pattern. So how did Thomas Young overcome this problem? By using only one light bulb and using the light from one light bulb to light up two slits. So even though the light from the light bulb is switching every few nanoseconds and the lights leaving the two slits are also switching every few nanoseconds, but because these two slits are basically lit up by the same light source, these two light waves are coherent with each other. Get it? Because they now switch at the same time and they switch into the same thing. So now we have two light waves which have a stable relationship with each other, and that enables us to observe an interference pattern on the screen. But we are not done yet. There's one more problem. And the problem is the light bulb is too large. So we do not have lights just coming from, say, the center of the bulb. We also have light leaving every point on the bulb. So the light from the center of the bulb will produce its interference pattern on the screen. At the same time, the light from, say, this end of the bulb will also produce its own interference pattern on the screen, but it's slightly offset. And the light from the other end of the bulb will also produce its own interference pattern, but again, with an offset. So can you see the problem? Because all their interference patterns are slightly offset from one another, they fill up one another's dark fringes. Without the dark fringes, you cannot convince anyone that there's an interference pattern, right? So how did Thomas Young solve this problem? Well, he added one more slit before passing the light through the two slits. So instead of using the whole bulb as the light source, he's using the narrow slit as the light source. So now the center of the slit will produce its interference pattern like this, and the other two ends of the slit will also produce their own interference pattern. But because the slit is so narrow, meaning our light source is so narrow, that each point of the slit produce interference patterns that are not very much shifted from one another. As a result, the dark fringes do not get filled in. And as a result, we can still see the bright dark interference pattern. So I hope you now appreciate what Thomas Young had to go through before he could produce the interference pattern. Alright, that's all. Ta-ta!